Okay, with this question here, we are going to look at an application, and we're talking about equations of tangents and normals. And remember that our gradient of our tangent is equal to the derivative at that point. Okay, so y equals e to the 2x, x plus 1 all squared. I notice that this will be a product and a chain rule. Okay, let's let u equal e to the 2x, b will be x plus 1 all squared, u dashed will be 2e to the 2x, and v dashed will be 2 times x plus 1. So y dashed will be u dashed v plus v dashed u, and that will be 2e to the 2x times x plus 1 squared plus 2e to the 2x times x plus 1. Now I'm not going to spend time rearranging that or simplifying it, because what I'm actually looking for is the equation of the tangent at the point when x is equal to 0. So I'm going to say that my gradient of my tangent is equal to y dashed, and I'm going to say y dashed when x equals 0 is going to be 2e to the 0 times 0 plus 1 squared plus 2e to the 0 times 0 plus 1, and that gives me 2 multiplied by 1 is 2, plus 2 multiplied by 1, which is 2, which is 4. Okay, so therefore I'm going to substitute my gradient of my tangent equals 4, and my point 0, 1 into my gradient point form, and that gives me y take y1 is m, x take x1, and that means I have y take 1 is 4, x take 0, so I have that y equals 4x plus 1. If I was looking for the tangent of the normal, remember that the gradient of the normal is negative 1 over the gradient of the tangent. So that would be negative 1/4. And again, into my gradient point form, I would have y take y1 is m, x take x1. So I have y take 1 is going to be negative 1/4, x take 0. And my gradient of my normal, which is my line perpendicular to my tangent, will be negative x over 4 plus 1. Something else I wanted you to remember was that the gradient of my tangent is also equal to tan of theta, and that theta there is the angle that my line makes with my positive x-axis.